Hello and welcome everyone to the new series of the AI Forensicator 30 Days Signal versus Noise Challenge, wherein I'll be covering living off the land binaries and how they can be used and misused, along with high fidelity detections that can come with it. So, in my first post yesterday, I had given a few living off the land binaries samples like certutil, which can be used for downloading in Windows, PowerShell for some executions, Rundll32 to run, to make use of existing dynamic link library functionalities, and likewise. We'll see one by one each one of them, so stay tuned with me. To begin with, today is day one of our challenge, and we'll be studying about Rundll32.exe. What I'll be covering today is these topics. What is Rundll32? Why does Windows need it? How does the normal look like? How does the abnormal look like? And how can defenders detect it? Obviously, top 10 high fidelity detections we'll be seeing after this. Now, what is Rundll32? So let me explain this with an example. Um, say when you're searching some control panel feature in this, say if you there are these all features, okay? Each one has a function associated with it. So these are under control panel. Now say if you want to click on this uninstall a program feature. This is programs and features. How else you can get here? You can copy this and in your file explorer you can directly run this. You'll come to the same point. As well as if you want to run it through a run CMD, what you can do is it is called appwiz.cpl. So we're going closer to it. You just run appwiz.cpl, it opens up. Okay. This is another way to do it. Now, third way to do it through CMD is to run this command in a CMD. It will open that. As simple as that. So run DLL32 is nothing but making use of existing features or the code that exists in run DLL in the DLL file, take the name of the function and pass the parameters to it. By that I mean, let me show you with a simple example now. Say this demo.dll. Now in this demo.dll file, there is a code written. There's this demo function, which does nothing but simply displays hello from a DLL, run DLL32 demo, okay, on two new lines. Now say I want to call it, the syntax of run DLL is this, in which we first name the DLL, demo.dll, then the function. So demo is the function which we are calling, and we don't need to pass any arguments because it's not asking for any. It's just void and we are not passing any arguments to it. So it's optional arguments. When we run it, this command, it directly shows this message. As simple as that. So this functionality, rundll32.exe, which is provided by Microsoft, can open the functions under control panel using this way. Okay. So as simple as that. Now, where do you find this rundll32, the legit one? Okay. You go to system32, C users, sorry, C Windows and system32. There all of these files reside. You can make a quick search by rundll32. So you'll get to see that file. If you right click and go to properties, sorry for that, properties, go to signatures or details, you get to see it's a copyrighted version from Microsoft and it's signed file. Okay, so you can see the signatures here. Now, this is how a legitimate rundll32.exe looks like. Now, why it is called leaving of the land attack? Because it makes use of this existing rundll32.exe to call malicious DLL files. Now these DLL files can be malicious, and so can be the functions in it. Okay, these are the parameters we can pass anything. Like threat actors might have created a code which might need a function and parameters. So according to that, he'll run this run DLL32 command line. Okay. Now, how does it look when this is run? So I have put a filter already to run DLL32 in process monitor. This when you double click it, it shows a command line which was run. Okay. So run DLL32 was run from system32 path, and shell32 DLL was called, in which control this function was called, and it was passed with this appwiz.cpl, okay, which again resides in the system32 folder where all the Microsoft signed files and binaries exist. So this is not writable part of directory. No one other than Windows, or there are set permissions. Other than that, no one can use it or write it. Now, let's see other functionalities of this run DLL32. I have a few examples to quickly show you how run DLL32 can be used in normal way. Okay, just need a command prompt, and so the same control run DLL, okay, which is nothing but control panel. That control panel can be used to change the desktop settings, desk.cpl using this. Okay. Now there's another example which is main.cpl. It opens the mouse properties, okay, and so far. So I'll just go through one more example and then we'll move ahead. To see internet properties, we make use of inetcpl.cpl. Now, how does a threat actor make use of it? Abnormal looks like. Okay, let's go to the given it in my screenshots if you want to see. Okay, I've not uploaded it yet. So I have stored it in my screenshots. Oh God. Sorry for that break. So this is few examples what abnormal looks like. These are the four malwares which had made use of this run DLL32 binary to execute malicious part of code. So Quackbot had used a JavaScript using run DLL32.exe, which runs this JavaScript and followed by functions. See, this is the DLL which it called and the function in it. So this is malicious. The second one being Emotate, which ran something remotely using a shared service, shared drive. So it was located somewhere else and it made use of this DLL file and the start function in it. Likewise, ISTID and Bazaar Loader also misused JavaScript and remote share execution. Okay. Now, how do we go around it? How do we build detections for these type of malicious activities? Let me bring this. Okay. So we have our first detection loading from user writable locations. So basically, if a file is being written, it cannot be written in system32 because it might have privilege issues. So we need to monitor paths such as app data, temp, downloads, desktop, or user public profile. So this Gusto query language device process events where file name is runDL32 and the process command line has these paths. So if it contains any of these paths, it might be a malicious one in the temporary paths. Now, likewise, coming to our second detection, run DLL32 loading remote DLLs. Like I had shown you before, the threat actors made use of this shared path, server, share, evil.dll, and the function name. So how we can detect this? using this Gusto query. File name is runDL32 and process command line contains double slash, which results into shared path. Third detection being using JavaScript execution. So if it starts with a JavaScript, obviously, so process command line contains, we can write begins with as well. Okay. But since it starts with runDLL32 and then there's JavaScript, it might be inside anywhere. So I've made use of contains. Now, fourth detection being spawned by Office applications, wherein Windows Word.exe, Excel.exe, PowerPoint, or Outlook.exe are the initiating process of runDLL32.exe. Fifth detection being spawning PowerShell. So runDLL32 very rarely spawns PowerShell um, unless the DLL has a function which is supposed to tell, which is mainly observed in the malwares family. So this is one more fidelity, but it has, you might need to fine tune it a bit, looking at your network, looking at your traffic in your corporate environment. Sixth detection being runDLL32 spawning lol bins. So this is one of the good example where one lol bin executes another lol bin. That way, like the all the files get unnoticed because their file signatures are matching. They are being called from system32. It's as good as like um, hiding in the plain sight. Okay. Now coming to detection number 7, we can if we are seeing network connections originating from run DLL32, that's another hint. It might be malicious. So network events looking for the run DLL32.exe, making connections to remote URLs. Coming to next, executing from temporary directory. So app data local temp. I had shown that earlier as well, but if it matches any of these app data temp or downloads folder, then again it's a point of concern. Detection number 9, run DLL32, very rare command lines. So how we can do is tail end analysis, in which we are seeing device process events originating from run DLL32.exe, summarize count, but sort it according to ascending order. That will result us in less, like the less frequently used run DLL32 command lines, which might show us the malicious behavior. Okay. Now, last one is my favorite, which I consider as high fidelity, is a combination of all these. So process is run DLL32.exe, and it the path contains of JavaScript or the shared path, UNC path, or the app data, temp, or local folders or downloads, which are writable parts of a directory, and there is a network connection originating from it, then it's a high fidelity alert for me. Now, this is a sample KQL query. Suspicious run DLL32 is equal to process events, which has file name run DLL32 originating process, and the command line has any of these JavaScript or app data, temp, local, or the shared path, followed by network events are observed from the rundl32.exe. That makes a very high fidelity alert for me. Thank you for joining. Do let me know if you need any other information about rundl32, as well as comment below if you want any of the lolbin attacks to be covered going further. Thank you for staying this far with AI Forensicator. Let's see you on day 2. Thank you. Bye.